Oh, what's up, everybody? Welcome back. Today we're working on making an async HTTP server in Zig. So the background is that we've been working on this like silly little website where we're running these like physics simulations. They're like balls rolling around, blah blah blah. It doesn't really matter. But what's happening here is we are doing the physics simulation on a server, and we are once per frame getting the like simulation state on the client. And this is working fine because we are sitting at the same location physically, and we are the only consumers of this thing, right? But there's like a pretty major problem with our current server in that it can only service one HTTP connection at a time, which is just like blatantly stupid, right? So if I like go in here and I look at like our like a little shitty little function that like opens a TCP socket to our server and then just does nothing, if I run this, what is it? Zig run. You can see like the simulation just stops because like I'm blocked on my client from getting any data just because this guy opened a connection. If I kill this guy, it's like it starts again. And so we need some sort of solution to make sure that we can handle more than one connection at a time, right? And so like the like super old school conventional way of doing this would be you spawn a connection or spawn a thread per connection, right? But that's pretty slow, or not like it's not like slow, but it's like feels incorrect, right? Having like all this overhead where you have like another essentially like a process, like a thread's like kind of like a process, right? And like he has like his own stack, and you have to context switch every time that you want to service some data, which means that you're guaranteed like a couple extra syscalls, like blah blah blah. It's just not really great, right? And so what we do instead is we want to say, how can we like monitor a bunch of connections at once and do actions based off of those connections all at the same time? And we want to like wrap an HTTP server around that concept. So what we did yesterday is we designed this like world's worst event loop, right? So we just took like epoll, which is a Linux specific thing, and we basically said, hey, we're gonna register like some handlers, which are just like I have a file descriptor, a callback, and some data, right? And every time that you see that there's some data ready to be read on a socket, just call this thing, right? And so we use like Linux's epoll thing, where basically to register we just say, hey, could you like add this thing to your epoll list? And we only monitor input events right now. That'll probably have to change. And then we made like this like kind of TCP echo server, so you could spawn a TCP listener, create new connections, handle those connections, blah blah blah. And so today we want to kind of extend this thing to work with HTTP. And so the plan of action is approximately we need some sort of like async sender and receiver. So all we did yesterday was we made async functions for accepting a TCP connection, as well as get notified that there is some data ready to be read from a connection. But then we kind of just assumed that if we called read and write, there would be no blocking. I'm like 95% sure that writes can block as well, and so we have to fix that, because you can imagine a case where, I don't know, we try to send some data out to a client and they just don't service our requests at all, and then we get kind of stuck being like, well, I'm waiting for them to like receive some data so I can send some more, and then that'll stall our whole process in the same way that just opening a connection does right now. So we have to fix that. Then we need to take like Zig's HTTP server and try to wrap that around like the concept of async sending and receiving. So when I looked at this a little bit, the HTTP server in Zig is pretty built around the idea of being blocking. So if we go to like receive head, I think is what it's called, right, you can see in here that they have a while true where they try to read from the socket. So we need to like maybe like dodge some of these APIs. Maybe we can reuse some of it, maybe we can't. We'll see where it goes. Then we need to make sure that like we have a way to like send async HTTP responses with like the correct headers and stuff, and then we can like integrate with our real application. That is the plan. That is the plan. How does Zig do async? Thread pool or something? Well, it doesn't do async at all right now, as far as I understand. And so we have written our own little event loop, which uses epoll, which will do the asynchronous for us, right? This is very similar to like if you were to do async in Rust. That's like effectively what Rust is doing under the hood, right? The future API in Rust is very like, oh, somebody will tell me that there might be some data here, and I'll check if there's some data there, and then I'll do something with the data, and then we'll wait for them to tell us again. This is the exact same thing, except without the fancy syntax for it. Yeah. Okay, let's get into it. So I just want to like double check first that sending TCP will block in some way. I'm like 95% sure, but I just want to double check. So let's make like some shitty little test functions or executables. Litmarv, thanks for the bits. So we'll make one function or one, sorry, process, and he's gonna like open up a TCP socket and then just never read from it. Right, so he's gonna like accept somebody. Somebody's gonna try to connect to him, and he's gonna say like, "Hey, can I send you some stuff?" And he'll be like, "Sure, do it. Go ahead." And then he'll just never look at it. And if we make a second guy that tries to send some data, we should see that that like falls over in some way. So let's import the standard library, and we can do like some address is equal to std_net address. I think it's IP4, and then we want like listen on all addresses and on port 8000 because that's what we've been using for testing everywhere. Then we want to say like, please listen with I don't give a fuck options. I guess we do give a fuck because we fall over on this all the time. So we want reuse port equal true and reuse address equals true because we're not going to like properly close this thing. And so the next time we run this executable, we want to make sure that like it doesn't go like, oh, the address is in use because you didn't close it. Like, shut up, okay? Shut up. Let us do it, okay? And then this will give us like some sort of like listener. I think this probably has to be variable. And then we can say listener. This probably has to be like try, and we can say listener dot accept, and so this will give us a connection. This has to be try as well, and then we'll just say this is like discard the connection, and while true, stood time sleep for 1 second. Time nanoseconds per second. There. Okay. So this is our like shitty little server. And then we can make a test3.zig. And we can say const std equal to import std. And then we'll just do the other side on this side. So we're probably gonna want similar code to this. Not exactly the same, but similar. So the address we're gonna be looking at 127.0.0.1. We're not going to make a listener, but we are going to have a connection that's got from std_net TCP connect to address. And then here we're going to want to write a big buffer to try to like make sure that we run out of room in like the kernel send buffer. I think what happens is like in the kernel, Linux goes like, hey, you want to send some data? Sure, I'll like pretend that I sent it like immediately. But if we don't, like if we fill that buffer, then I can't pretend that. Like you can't give me more because I'm not going to like, if you try to send a gig of data and they just never listen, I'm not going to buffer a gig of data in RAM. So I think that we can just say like, let's make a to write is like some allocated buffer, which means that we need an allocator. So var GPA is equal to std heap general purpose allocator with no empty config. And then we, oopsies, I fucked up the brackets there. I wanted braces, not brackets. And then we defer GPA dinit, and then we get our allocator interface from the general purpose allocator. Bing, bang, boom. And then down here we can say, okay, we want to allocate like 10 megs of data or something. Is that 10 megs? KM, yeah, 10 megs. I guess it's technically 10 megabytes, not 10 mebibytes, because it's not a power of 2, power of 10. But let's see. What is Zig used for? I mean, it's like a general purpose low-level programming language, right? So anywhere where C, C++, Rust fits, it's like the same shit, right? It's kind of like niche is that it's like imagine if C++ were written now, kind of like not exactly, but like you can think of it that way, right? So like take all of the mistakes from C++, get rid of them, keep the simplicity of C, but add generics and like safety essentially. But not to the extent that Rust adds safety because we don't want to trade like they want to be pragmatic. We want to like keep simplicity. Rust adds a lot of complexity to add some safety. You know, we'll add safety to the point where it's reasonable but still simple, kind of. I don't actually, that's kind of like my impression of it. I should say that I don't really know the motivations of anybody else in the world. I just know what I think their motivations are. Okay, so here we're just going to want to say like, what do we want to do here? We want to write this stuff. So we just say connection dot write all to write. And if this does what we think it will, when we run these two things together, this test3 should hang forever. So zig run test2.zig. And then we should say zig run test3.zig. He doesn't like something in here. Member expected 2 arguments found once. The allocator needs to say, hey, I want to add 10 million bytes. So I need to tell it what it's allocating. He doesn't like that I didn't write try here because this thing is failable. And what else? Okay, there we're chilling now. Run test2. Run test3. Okay, so good sign, but maybe we fucked up in some way, and like we're just like stalling no matter what. So let's try setting something really small, like instead of 10 megs, let's say like send size is equal to 1K instead, and we'll do send size here. So now if we run that same test, we run test2, we run test3. This guy should exit. Good, he exits immediately, which kind of indicates that like it's sent. Maybe we could even, I was gonna say we could print what we got on the left side, but the whole point of this test is that we're not reading the thing on the left side. So, I think that's reasonable. I think that we have kind of proved to ourselves to some extent, that this is a necessary concept. I guess we could put what else we could do is we could put the sockets in non-block mode, or instead of using write all, we could say like while true, we could try to write some amount, and so we'll say like we wrote this much. Write idx is a use size equals 0, and we can just like increment write idx every time we go through this loop. And here we'll say while write idx is less than equal to or equal to 2 write len, I guess less than 2 write length, we will write from write idx to write len. Okay. And then maybe we'll even like log here. Std debug print writing from this location. Okay. So let's just make sure this compiles. Looks like we're chilling. Test2, test3. So he just like kind of hangs on writing from 0, which is kind of interesting. I kind of expected that write call would return with how much the Linux kernel could buffer right now. But I guess maybe I have to set the socket in non-blocking mode, which I can never remember how to do. Linux socket non-block. Non-O block. Right. So we use fuknatul to get some flags. We set the non-block flag and then we set the flags again. Okay. So if we wanted to like set this to non-block, we could look at our connection dot what's in here, handle, and we could do something like fc POSIX maybe, std POSIX fc ntl. Perfect. We can use our handle here. Somebody's saying that I don't have to write to write.len here. I think that is true. I think it also doesn't matter that I wrote it though. But I think you're right. The command was f.getfl. So I think in Zig they wrap everything in these like enums. So I think if I go to POSIX f and I say get fl, nice, that feels about right. And then they wrote 0. No, they wrote 0 in here. So this is flags. And then they set flags, and if we want to block, we turn off non-block, and if we don't want to block, we turn on non-block. Okay, so flags or equals std POSIX non-block, I think, maybe. O is system.o, which comes from Linux, and in here he has a non-block. Oh, gross. This is a packed struct, huh? That's a pain in the ass. So that means if we wanted to use it as a packed struct, we have to go like pointer cast and flags to a pointer. Well, how does pointer cast work? He infers. We'll say var flags struct is equal to a std POSIX and then we could call it like a pointer to this thing. I don't know if pointer aliasing is like a problem in this language. This is like a good chance that this doesn't do what I want it to do, to be honest. But that's okay. So non-block is equal to true. And then we just go back. So we say, I think we have to discard the result of this thing, so we don't give a shit. And I think these probably have to be try, actually. Almost certainly. Yep. And here we want to set FL this time, and we set the flags. I'm honestly like very unsure about this. I know that like in C there are all sorts of funny rules about what you're allowed to pointer cast to what and like in what context you are, and I can never remember the rules and have to look them up. So there's a chance that this is invalid. It would probably be safer to like bitcast the thing and then bitcast it back. But I want to try this and see what happens. Okay. So zig run test 3. Okay, so it compiles, which is good. And so if we run zig run test 2 to run the server, we run zig run test 3 to run the client, hopefully he says, hell yeah. Okay. Error would block. That's a really good sign. Really good sign. Okay. So we've proven, I think that I am relatively happy with this proof that this is a thing that we need to do. So, I guess this was actually prove, prove. I don't know why. Why is groove 2 O's, but prove is 1 O? How confusing. What a stupid fucking language. So we wanted to prove async TCP send is required. Yeah, bitcast whenever possible, safer than pointer cast. Yeah, I mean, I agree, but also, like, how am I supposed to know? I guess that I would probably the reasonable thing to do is assume that it follows C rules and then look up the C rules. And I think that like, I think my recollection is that it's actually probably okay if you do it within the function. It's the when you take in pointers to a function, you can't like the compiler might assume that those pointers don't alias each other, but if you do the cast within the function, then it knows that those are aliasing pointers, so it's probably okay. Probably, but it is a little sketchy, super sketchy. I know that also, I think in like the C spec, you're allowed to cast from U8 to any like single byte pointers to anything, but casting from like a U32 to like an F32 is like actually technically undefined behavior, if I remember correctly. But Zig might fix some of that stuff. I don't know. I don't know. Okay, so let's do some async TCP. Async TCP. Okay. So we need some sort of thing where what is it gonna do? We're gonna have like some TCP socket, and we're gonna have like an event. Epoll is gonna tell us that it's ready for read. I guess we technically kind of have a TCP reader right now in our echo server. The reading is kind of asynchronous. If we set this to non-block, I think that it would be almost there. So it's kind of like the writer side that we need to figure out right now. And so if I wanted to say like async write this buffer, and say I was gonna do that from the context of my TCP echo server, I would like run this function echo, and I would like queue up this thing to respond. Now, whether or not I need to like copy the data out, kind of I guess depends on where the data comes from, right? So like if I was going to say like async write hello world, this is going to be like statically, this is going to have like a defined location in memory, and I don't have to worry about like freeing it or something. But if I wanted to do like something where I'm like, you know, read this file and then write it out, if I were to like read the file first then I would have to like buffer I would have to like save the entire contents of the file somewhere, so that as I am polling this thing and saying, can I write some more? Oh, I can write 10 bytes. Okay, can I write some more? Okay, I can write the next 10 bytes. I would have to like have some sort of like buffered data there. But I wouldn't have to do that actually if I just stored the file that I was reading from. So maybe we should think about this a little bit in the context of how we're going to be using it in our like actual server. Right? So in our actual server, I think that we serve both files as well as like JSON responses. And so those, I guess, probably will end up being like two different state machines, right? One will be like read some bytes from the file, then stick those out, then stick those somewhere. Although I guess you wouldn't really want your connections being blocked by I/O, right? If I have like two files that I'm serving from anywhere, right? I've got like my index HTML and index JavaScript. It would be kind of silly to hit the disk every single time anybody wants one of those. So maybe we'll like mmap them in. Maybe we'll just like read them when the server starts and then like keep them in memory because like fuck it, why not? Because we're not actually like, there's not that much data that we ever have to serve in our specific context. So okay, let's kind of work under the assumption that we'll be serving from memory from now. And that memory will outlive. Okay, so there's like I guess there's two contexts here. One is the JSON serialization case, right? So somebody says like, hey, could you give me the simulation state? And we like snapshot the state and we send that immediately. And then there's also the other case where it's like, okay, we have a file that we've mapped in and we want to serve that. So we have to support both the case of we have to support both the case of we allocated some memory and we didn't allocate some memory, which is fine. We support that. Okay. So we'll call this like TCP writer. And he's going to look a lot like this TCP echoer. Does he need an allocator? He might. So allocator connection. So this is where we're writing to. This is where like who owns our data. And this is a reference to ourselves, kind of. So these like event handlers, the way that we set this up is that our event loop takes an event handler that has to have like a static location in memory. This event handler structure gets passed to epoll, and when epoll sees something happen on a file descriptor, he says, oh, here's that structure that you told me about. And then we call this like function callback with this data. So that's why this guy holds a pointer to himself, is because it needs like a stable location of memory. So we will like allocate that thing and then free it later. Allocate, register, free. Which means that probably our init function is going to look very similar to the init function of the echo server. We're going to take in an allocator, we're going to take in a connection, we're going to return a TCP writer. And we are going to create ourselves. And we are going to create an event handler, and we are going to say, hey, when we are finished with this thing, we have to free ourselves and close the connection. This is all exactly the same, which is sick. Right? We close the connection, we free our handler, and then we free ourselves. And then this handler is going to maybe have like a write function. dinit is going to be dinit. Data is not echoer, writer, we should call it. And then we assign our own content, which is this, and we return ourselves. Chillin'. Okay. This needs to be writer. And then we need some sort of write function. So what do we do on write? This guy is assuming a very specific API. It's expecting to be this callback thing. So let's copy paste this over here. So function write takes in a event loop handle as well as user data and returns nothing. Okay. Well, he returns maybe an error. What's it mad about? Oh, I put a space there when I shouldn't have. Okay. And then we're going to do something like self is a TCP writer pointer, and this is pointer cast from the user data. And then we can do something. What are we gonna do? I guess we are going to assume that we're in non-blocking mode. In fact, we should set non-blocking mode when we construct this thing. So we can kind of copy paste this and say const set function set non-block. We can just paste this shit from earlier. This is gonna take in a connection. Stream, I think, is what we're taking here. Why is user data opaque? Because we don't know. We have like support for sending multiple things to our event loop, right? So our event loop will say, hey, I think that this socket is ready to be read. You do whatever the fuck you want to do with it. And so because of that, there are like multiple types of data that could be set up with this like callback. And so we need to make an opaque thing so that the function signatures for any type are the same. You know, kind of like C-style inheritance type shit. Okay. So he's going to write something into this connection. Oops, I forgot to set non-block. So here we were gonna say try set non-block connection stream. Okay. Is this failable? It's not, but it should be. Okay. And then we can on write basically just try to write to the stream something. I guess we need some sort of like buffer to write from. We also need to give it some data to write. So let's say that we were to give it just like a slice of memory. Sure, we'll start there. And we'll keep track of what we've given it, so what we've written out? What we've written out. What we've wrote it out. What we write it out. Wrote. Wrote. What we've written out. English is so hard, man. Buff equal buff. Buff IDX equals 0. Don't want to distract. What computer laptop do you use? This is just like some hand-built desktop from like 10 years ago. Are you on NixOS and Plasma? Yep. Written is the only correct one. Okay, well, we're righted. I'm gonna say righted anyways, okay? Huzeets, thanks for the prime. Appreciate it. Okay. So every time we write, we're just gonna say, we're gonna try to write, and if he returns would block, we're gonna do something. So we're gonna say like self buff IDX plus equals the output of write. We're gonna try to write our buffer from buff IDX onwards. And is that it? Is that the only thing we have to pass in here? Yep. And then we're gonna catch an error. And if E is equal to error would block, I think is what we saw. We're gonna do one thing. I guess it's just return. Ooh, yeah, I think that's fine. And else, we will return E. So in the case that we get a blocking thing, we're like, fine, that doesn't matter. We'll just do it again later. But if we get any other error that's unexpected, and we should like indicate that there was some sort of error. Now, if buff IDX is greater than or equal to self buff len, it should never get greater than, but just in case, we basically want to say, hey, can we fucking stop calling me? Stop fucking calling me. We broke up. You know, you have to leave me alone. Move on, epoll. Which we'll call this, and then we'll go away, and everyone will be happy. Okay, so I think the remaining problem here is there's a couple things. One, there's three, I think 3 things that I can think of right now that are problems. One is that buff has no way to mark ownership, right? So if somebody tries to give us a buffer that we have to write out that we're gonna have to free later, we have no way of dealing with that. 2, Epoll is configured to only poll on input, which is bad. Three something. What is the third problem? I had it. It was in my head. I've lost it. Fuck. No, it's gone. Okay, whatever. I'm sure it'll come back to bite us later. Oh, 3, composability of this is bad. So, if we wanted to like wrap this with an HTTP server, I'm not 100% sure that would work. I guess we would just call the TCP writer with the HTTP data as our buffer. So maybe that's fine. Maybe we can discard 3 for now and think about it later. But okay, let's at least address epoll configured to only work on write or on read. So I think it makes sense if epoll can tell us if something is ready to read or something is ready to write, then we should just expose that somewhere. So where does it come from? On register, probably. Function register. Here we go. So here we basically unconditionally just write input here. And how do we want to deal with this? So we could just write like direction here. I don't know how much I think that's reasonable, right? The more data we stack in here, the less efficient each TCP socket becomes, but also it doesn't really fucking matter because no matter what we do, our implementation is going to be inefficient as fuck. So maybe that's fine. Another option is to just write std os linux epoll out here. And if we just always do both, we can just say that like our sockets can be polled in scenarios where they don't necessarily have more work to do, and they should just support that. And that's easier to me for now. It will result in maybe more wake-ups, especially if you have 2 handlers registered to the same socket. But I think that probably in our usage, it'll be pretty serial. We won't be like, hey, could you tell me when like this thing is I'm gonna like handle read and write at the same time from the socket. Probably what we'll end up doing is we will like flip flop between write mode and read mode, right? So we'll start by being like, okay, I want to read from this socket, and then when I've got some data, I'll append a writer to this thing. Oh no, I guess our read socket will probably stay around forever. So maybe this is like a little shitty, but it's fine. It is fine. It's not the end of the world. Not the end of the world. We can kind of like monitor how many like spurious wake ups we end up with. In that case, I guess they're not really spurious. They're kind of known why they're happening, but they're like useless wake ups. We can like keep track of that. I don't think it'll be too bad. Okay. Actually, there's a problem here for sure. Actually, fuck. So I think epoll only has like 1 epoll notification per file descriptor. And so if we were to try to add an epoll callback, or I guess like, so the way epoll is, from epoll's perspective, he's just like, I've got file descriptor and number. And when this file descriptor does something, I will give you number. And so if we want to say we have like 2 functions to run, we can't register that with epoll, I don't think, because epoll will give us 1 pointer. And so what we actually have to do is probably need to look up a list of functions that we have to run for a given file descriptor. Because like if we're reading and writing to the same TCP socket, we just have 2 functions to run. Now, I don't know if that's really true, that epoll can't handle 2 things, but we can look at maybe the documentation. So we can look at man epoll CTL. And let's look at like its error cases. So I'm assuming that it'll be like, hey, I can't fucking do that if you try to add the same thing twice. So we can look at maybe like errors. Here we go. Exist. Yeah, okay. So this is exactly what I was worried about. So it kind of makes sense. The API doesn't really give you a way to like unregister one of the 3 handlers that you've given it, so it makes sense. So we're just gonna have to change this a little bit. Okay. So before we get to any of this TCP related stuff, well, first let's build. Let's just, how fucked are we right now? Not fucked at all. That's very good. So let's maybe start by doing a little side quest here to support multiple callbacks per whatever the fuck file descriptor. The new progress bar is fancy. Yeah, super fancy. Pretty cool. Pretty cool. Okay, so I guess instead of giving it a pointer to our event handler, how do we want to handle this? Somebody's going to say, hey, here's an event handler that we want to run. I guess we just have to stash that in a map somewhere. I don't think we really have much of a choice. Which we actually already doing in order to free stuff at the end, so it's actually not the end of the world. So we can just say like handlers goes from a new handlers we'll call it for now, and we'll delete the old ones later. This is going to go from like an I32 to like an array list of event handlers. Maybe? Is that what I want? That's option 1. Option 2 is we hard code a maximum here, right? Like you can say you can only have 5 handlers. I don't think that's really reasonable. Maybe it is. You could also say that you can only have 1 reader and 1 writer. So you could do like readers and writers. What do I like most? Right, then you just have this. I would like to avoid the map to an array list if I can. I wonder if there's a type in Zig's standard library that kind of goes from like 1 to many. Right, if there's something that like already kind of handles this for me, then it's not too bad. Where did you used to work and why did you quit? I used to work at a company that did like neural networks for picking up stuff out of a box. So they have like, robot arm, 2 cameras pointed into a box of stuff, and they want to be like, okay, I want to like precisely find that thing and put it in the robot's hand so that I can like do something with it, like put a screw in a hole or something, right? So there's a lot of like neural network stuff going on there. That's mostly what I did, was like work on their neural networks. Not like so much on like neural network design, but more like training process and bug fixing. So, there's some problem with the data or maybe some problem with the network. I was like looking at that stuff a lot. I used to work at this like camera company that made like camera firmware. So like you have a box with some circuits in it and they give it to you and they say, please make run now, please, man. And then you get to do like Linux boot up and stuff and like work with the DSP in the thing to like get H.264 encoded frames and send them over the network, stuff like that. And why did I quit? I was tired. I was like, I don't know. I think I have like a personality type where I just want to do the best that I can on something. And so in an environment where you need to cut corners in order to like make progress, it is difficult. It was difficult for me to say no, especially when I thought it was possible, right? So somebody's like, can you do this? I'm like, yeah, I can do that. Of course I can do that. And they're like, can you do this? I'm like, of course I can do that. And then there's like 6 months where you're just like, oh, I didn't really do any of the things that I wanted to do, and that's like frustrating and tiring. So not really, any fault of anyone but myself. But I got a little tired, and then I was like, I will do coding for fun now because that's more fun for me right now. So we'll have to go back at some point unless we make enough money from streaming, but for now, we're just enjoying this. Okay. What was I doing? I was trying to decide how I want to structure this stuff. I wanted to look at the Zig standard library to see if they have some sort of like map that kind of merges the concept of like a hash map and an array list, so they like, one-to-many pointer essentially. Probably they don't, but if they did, that'd be kind of nice. Auto array hash map. This is array hash map with default function. So an array hash map. What is this? What is this? A hash table of keys and values stored sequentially. Oh, I see. I see. So this is like this is like, I have key like A, F, G, K or something, and then these map to like 1, 2, 3, 4. And so like I like look at the keys list and I'm like, I want to look up the thing at K. And it will like find it in this and like find the index for that and like extract it from here probably. Multi-array list under the hood. Yeah, that makes a lot of sense. So that's not what I want. And then array hash map on auto array hash map is just like the same shit. String hash map, auto hash map. Yeah, I mean, I don't think it's really like, it's fine. They don't really have it, which is reasonable. Totally fine by that. Okay. Yeah, I guess the third option is like link list it, but I don't want to do that. Okay, fuck it. We will do this. We will. We could get a little fancy here, right? There's kind of like the expectation is probably that you have one. Do you like one handler for each socket? For like for the normal case? Maybe not. Maybe not. Okay, fuck it. Yeah, so maybe we'll do this. We'll do you could do something like new handlers because we don't want to get rid of this yet. And then like extra handlers. You could do something like this. Where like for the happy path you only have one, but then sometimes you like have to take that double indirection. In reality, it doesn't matter. It doesn't matter. We'll just do this. We'll do this. It doesn't fucking matter. Although we also need to figure out how to remove a handler from this list. So somebody's going to be like, for TCP socket 1, 2, 3, 4, for TCP socket 1, 2, 3, 4, register reader callback, register writer callback. And then they're going to be like, okay, I finished writing. And then they're going to have to like delete this guy. So event handlers are going to have like kind of like their own unique IDs. Right? So maybe this gets like a usize. And then you have like handlers which have like go from like usize to event handler. Also array hash map will win unless you're removing a lot. Yeah, I guess that's true, huh? I guess that's true. I was thinking that like insertion is not great, but because it's like two maps, it kind of like, yeah, it feels pretty good. Let me think about this. So in this case, we basically allocate a new ID for each thing. I guess you could maybe pool the IDs that you don't have to work, like you don't have to keep incrementing forever. So you could do like ID pool. Handler ID pool is an array list of usizes. When we register a new thing, we say hey, we will like look in this pool for a new one. If there is no IDs available, we'll like make a new one. Then we will use that to look up our specific event handler, and then we also have to map from epoll file descriptor to this thing. Oh, that's so gross. But I don't know if there's like a way around that. Yeah, because we need to uniquely identify every event handler, and we need to tie event handlers back to file descriptors. There's no way around that. I guess technically you might be able to ditch this guy, the list of IDs, because if we just if we gave to the epoll system this array list, then we could iterate this thing directly, and we don't have to look up anything. Yeah. Yeah, that feels okay. Maybe. Although, then what happens when we try to deregister an event? We would need to ask epoll what pointer it would give us, which is maybe it can do. Change the setting associated with FD. Can I like ask it about things? Like, can I get like current event struct? Epoll query current event struct. I found a solution to my problem. If you are monitoring for epoll or read-up, you can call shutdown socket, which will trigger your socket and allow a handler to clean up. Okay, he's kind of saying, they're basically kind of saying that you can't really do that. Which means that I need to keep track of this, I think, because what's going to happen? I'm going to try to deregister. I'm going to say, hey, I'm fucking dunzo. And epoll, you have to know that I'm dunzo. Yeah, I think that we do need to, this is necessary. This is necessary. Now, again, we have to be careful as well. This hash map is going to, the things in the hash map don't have stable memory locations. So if we want to point to this array list, we actually need to do this. Jesus. I guess. Hold on. This struct is at least 64 bytes larger than it could be. Yeah, definitely we're wasting some stuff, for sure. Epoll. Okay. Each allocator in those unmanaged collections is 16 bytes. Yeah, I'm not worrying about that for now. I know you're right. But it really, at the very least for this stuff, I'm not worried yet. We can always go back and like slim it down if we need to. But for now, I just want to get something that like feels sane and works. I'm more worried about the like the state management bullshit that's going to come from this, right? Like the more state that we're keeping track of, the harder it is to like deal with. More than I'm worried about like the byte size. You know? Okay. I guess we'll start last ID here. We'll start here, maybe. I'm not sure that I have the whole picture. So what is the process here? Register. When we register the reader callback, he's going to give us a handler ID. When we register with epoll, we're going to give him he's going to give us back this I32, which is the file descriptor. We're going to look up the file descriptor here, and then we're going to iterate this guy. No, we already said that we were going to give him the array list directly. Did we say that? I don't think we can maybe walk that one back as well for now. So he's going to give us an I32. We're going to look up the handlers here, and then we can just run this event handler directly. I don't think we need anything else. Yeah. Except this is probably going to need to keep the ID as well. And I guess we'll use U64s here instead of usizes because we just want to make sure that like we can give out as many as we want for the rest of time without worrying about overflowing. Oh yeah, that feels like it'll work. This feels like it'll work. And I think that it's probably better to just try something now, and if it feels like it's shit, we'll deal with it. Okay. So we'll delete this thing. Fuck this noise. And we'll just kind of start sorting through how it's fucking broken. 195. So he was working with handlers before, now he's going to work with new handlers, which is going to go from I32 to std array list. I guess we'll name this thing. I guess we should name it. So we'll say epoll handler data, epoll handlers is a like std array list of, we'll have an epoll handler, which is a tagged handler. That feels right. Tagged handler is a struct which has a ID, U64, as well as a handler, event handler. There. Then our handlers is going to be an array list of tagged handler. And then this auto hash map goes from I32 to handlers. There we go. And then down here, we can say that this is a I32 handlers init alloc. Boom. 172, he's mad about something. This needs to be a comma, not a semicolon. And we're missing last ID, so 198. Last ID is equal to 0. All right. And then here at 241, we have to figure out what we're doing when we are constructing these guys. So this is no longer going to take in a const event handler. He's just going to take in a raw thing. We are going to unconditionally put that in our handlers list. So self handlers. And I guess he doesn't need to really hold his file descriptor anymore. This will kind of come in here. And so we're going to say self new handlers put at this file descriptor, this handler. But we're going to have to give him an ID. So const handler ID is last ID plus 1. No, self last ID plus equals 1 here. There we go. And I guess we could technically do like an error defer last ID minus equals 1, but that doesn't fucking matter. Get or put, that's a good point. There might be handlers there already. So this is, we can say, hey, can I please get the thing for this file descriptor? Yeah, and what does this give us? This gives us a get or put result, which is going to say, the key exists, this function cannot fail. If there's an existing item with key, then the results entry pointers point to it. Otherwise, puts a new item with an undefined value and the entry pointers point to it. Caller should then initialize. How do I know found existing? I see. So we can say if handlers found existing is not true, we have to make a new array list. So we have to say handlers dot value pointer is equal to std handlers init with an allocator. Which means we kind of have to stash an allocator somewhere. Oopsies, where the fuck am I? I'm lost. Oh god. Okay. Otherwise, we're just gonna do handlers dot append. No. Value pointer append. A thing that has ID of handler ID and handler. Yeah. Sure. Which means we have to pop this thing if this fails. And I guess here, the thing that we are appending is no longer the pointer here, but we're going to use the file descriptor field and put file descriptor here. Yeah, that feels right. Then we return a handle. And what is in this handle? A pointer to the event loop and a pointer to our handler. This doesn't feel right. Instead, we will store the handler ID, which is a U64. And I guess we're gonna have to store the file descriptor as well. I think we need both of those things. Yeah. And we need the... Fuck. What was it? Handler ID? Is handler ID. Okay. Now, this is not going to work all the time because this might already have this thing registered. And we could either just unconditionally try and handle the error case, or we could just only do this if the handler's size is 1. Yeah, sure. Yeah, that makes sense. I think that makes sense. So we have a handler ID. Handlers is this like thing that we get if we forgot to push the thing. This feels wrong. This is like this. New handlers, we remove the file descriptor. Yeah. Remove the file descriptor if we fail. And then here we pop the thing if that fails. Yeah, it feels like everything is set up here. We need to make sure that we remove our thing on dinit. So here, when we unregister our thing, I guess we're first going to find handler in handler list. If handler list is empty, or remove item from handler list. If handler list is empty, unregister with epoll. Yeah. So we'll say self event loop new handlers get self file descriptor. Okay. Handlers, what is this? This returns a optional value. I don't want an optional value though. I want a pointer to the value. Am I high? Get pointer. Yeah, nice. Get pointer here. And this is going to be maybe not there, but we can maybe assert that it is. Is not equal to null. Then we can say stood mem index of, and we look for our event. What is it called? Tagged handler. We can't just do stood mem here. We have to loop over them. Function somewhere. Function. I don't know, man. I don't know. Function find handler. And he's gonna give me a usize, I guess. And he's gonna look for the handler ID in a bunch of tagged handler. But this comes from event loop. Is this right? Yeah, and then we'll just say for 0 to handlers len if handlers I.id is equal to handler ID, return I. Return null if we don't find it. Simple. Simple. So then we can just say const handler ID is equal to find handler, given our self handler ID and the handlers items. Yeah. Okay. Then we want to swap and pop that thing. So handlers swap remove handler ID. We'll just assert that this is true as well, because I think it should always be true if this is being called. I think that's a bug if it's not. And I don't think that we actually need the handler anyway. I guess we might, because we might need to dinit it. So that happens here. If handler dinit, we call the dinit function. And then we unregister if handlers items len is equal to 0. We do this, remove the thing, as well as handlers. We also remove the thing, this item completely. So event loop new handlers dot remove self file descriptor. Yeah. Yeah. Sure. I feel like I might have missed something, but maybe not. I'll have to be careful with GDB at some point to look at this, but for now, let's just kind of keep going. What is going on here? Fuck this. Okay, yeah, so let's think about this again. So we get the handlers for this file descriptor. We find if our handler we find the index of our handler, we remove that index, and then we check if we have no more left, then we remove the complete list. Here we actually need to call handlers dinit first. Then we remove that entire thing, delete the epoll thing, and then try to run dinit for our handler itself. Fuck it, blaze it. Seems fine. Seems fine. What else is broken? Missing alloc at 209. So we stash that shit. And you guys are like, use the unmanaged versions and pass alloc in. I'm like, fine, I will, but not right now. Not right now. Not right now. So this now needs to register with the file descriptor externally. So TCP server stream handle here. And then I think there's another one where it's going to complain as well. This is supposed to give this thing by value now, not by pointer. 253, he's mad about this. He wants it to be tried. 257, we need to discard the thing we pop. That's fine because like it's returning a value, but we don't give a fuck what the value is. In our error handling path, we're just trying to make sure that we didn't like leave anything behind that we shouldn't have. Here he's mad about Ah, I see. So when we receive an event, we no longer have a data as an event handler. We get the file descriptor out of it, right? That's what we registered with, data FFD. And so this is now, we don't have to do like a pointer cast anymore. We just do file descriptors this. And then we say self handlers get at file descriptor. Then we run each of these things. Except we can't do it by pointer because the callback might de-init himself, right? He might say like, oh, I'm done, so I'm going to delete myself. And so if we iterate these things by pointer, that's going to be like a fucking problem because the pointer might become invalidated, I think. I think that's like a very real risk. So instead we will actually call get on this thing and copy it out. So we'll say handlers is this. And then for each handler, we are just going to call handler dot handler. Is this not right? Hello? Oh. We'll dereference this thing. Okay. Handler dot, what is this thing? This is supposed to be tagged handlers, right? Oh, handlers items, of course. Then this thing should be a tagged handler, and so we should hit handler.handler.data goes into handler.handler.callback. But we need to construct a handle here too for him to work with. So we have const handle, which is, dude, what fucking overloaded words, huh? So we have a handler which also gets a handle to the event loop. Which is disgusting, but we'll live. Handler ID is the handler.id, chillin'. And then event loop is just a reference to self. Good thing that this still works, or else I would have been mad. This is handle, not handler, and then we have we pass the handle and the handler. What a funny line of code. Handler.handler.callback handle handler data. What a disaster, man. What a disaster. That's really funny. Okay, what else is broken? No field FD at 124. Right, so this is more handler construction shit. So this can just go away, and I think it's fine. Except we need to up here when we register this thing, we need connection stream handle here. Okay. Expected type this, found that, because this actually no longer has to allocate for himself, which is kind of interesting because we're stashing the event handlers now. So this guy actually doesn't need this at all, which means that kind of this can go away. He still is going to need to give him his deinit function. So maybe it makes sense to maybe event will make a function to like get the handler out. So self is a TCP echoer, and we return event handler. And this is going to look a lot like this. So this is just return this, boom. And then all of these just have to get renamed. There's no name collision, fine. Yeah, I think that's fine. This needs to be like this. And then on destroy, we don't have any handler to destroy anymore. We just destroy self. Maybe. Might work. So up here, when we register our echoer, this is like this. Not quite. No field handler at 113. 113. Here we go. Right, so this is... What the fuck is going on here? Oh, we don't need this anymore. Right, that makes sense. 213 on deinit, we are now iterating over new handlers, which is fine. Not a big deal. I32 does not support field access. So this is no longer by keys, this is now by so this is we need another loop here. So this is the map of function or of file descriptors to handler lists, and then we need to say for al items. Now we can do this. Whatever we were doing before, d init. So if item d init, we d init with item.data. Then we have to say al.dnit here. And then I think that this is fine. I think that cleanup is probably okay now. No field name items instruct hash map unmanaged dot entry. Fuck. Value pointer dot items, I think. Close. Okay. So no field dnit here. So this is item handler dot dnit, item handler data. Fuck me, man. Al value pointer dot dnit. Okay. Please, please, I'm gonna lose my mind. There's too much memory management. Too much memory management. He doesn't like d init there on array list line. Oh, so this has to have a question mark on it. Fine. Fine. Bool ignored at 188. So I don't give a fuck about that. That's fine. 190, we are supposed to use self.ft here now because we changed a bunch of shit. Oh my god. Oh my god. This is just like this. Handler dnit. Handler data. Ah! 123. Echoer. Wrong name. Please. Okay. What do you think the chances are that this works? Like, so what this is supposed to do is we've changed nothing. We've just kind of changed our data representation, and we should hope that our echo server still does something sane. I'm betting it doesn't work. That's my bet. Zig build, and we run our event loop test. So let's telnet localhost 8000. Fuck. If it compiles, it's segfaults. Yeah. It is the Zig way. Okay, let's see. Telnet localhost 8000. Hello. Okay, so it's still echoing. That's very good. Hello? Echoing twice still works? Never type exit? No leaks logged? No fucking way, man. Okay. Can we do our, like, a test under Valgrind? I think there's, like, a Valgrind option to look for unclosed file descriptors, which is important here because we want to make sure that we're cleaning up right. So it's track fds equals yes. Track fds. Remember that, guys, because I'm going to forget. Track fds equals yes. Track fds equals yes. Okay, so this always complains about like when we allocate stuff with the Zig allocator, he basically tries to probe the stack from like his current stack pointer all the way up. So he goes like, who's my parent? Who's his parent? Who's his parent? Who's his parent? And he just like asks the operating system over and over again. He's like, is this a pointer that I'm okay to look at? Is this a pointer that I'm allowed to look at? Because eventually he's gonna get all the way up the stack and it's like no longer a valid pointer. And so this is what these like Valgrind things are complaining about. Basically like that, right? Stack iterator is valid memory. Stack iterator is valid memory. So we don't have to worry about those. But we do need to worry about anything else that it complains about. So this is fine. We do it again. Hello, exit. A little bit of a problem. Oh, I've seen this before where sometimes Valgrind, when I open my Nix shell, ends up with a bunch of like extra file descriptors that it shouldn't have. So I'm just gonna maybe exit this shell and run it again because I'm not confident that these file descriptors are the ones that we care about. I don't think Valgrind catches leaks from GPA, only the allocator. Sure, but the GPA will catch leaks from the GPA allocator. So I'm more worried about, I'm using Valgrind here to check that we're closing everything that we opened. If that makes sense. Hello, quit. Oopsies. Telnet, hello, exit. Okay, so it does look like inherited from parents still. This shouldn't happen. I'm pretty sure that like if we look at this IP, I think it's GitHub. So I think that what happens is like Nix does like an exec to ask GitHub for some packages, and then they get like kind of stuck. Or there's a virus on my computer. Okay, there we go. Back to 3. Okay, so we have 3 if we don't do anything. So now let's try this again and see if we do telnet, hello, quit, hello, exit. 3. Okay, yeah, so we're not leaving anything dangling. Or virus. I'm pretty damn sure. So this only happens if I Nix shell after not having Nix shelled for a while in the context where I have a fetch tarball from GitHub in my Nix like environment. So I'm pretty damn sure, right? If we look at what that pointer is, or not the pointer, the IP address, we can do like who owns this? Last time I looked this up, I feel like I saw GitHub. So I'm pretty sure it's not a virus, but the first time I saw it, I freaked the fuck out, man. I was like, why the fuck does my shell just have open sockets to GitHub? What the fuck is going on? But anyways, feels okay. Okay, so it looks like we kind of did our refactor and nothing went terribly wrong, except we're not testing the case right now where we're registering 2 callbacks for the same thing. But what we can do to test that is really easy, actually. Feels okay after restringing. I would freak out too. Yeah, yeah. It's like, no, someone's in the like. They've made it so deep in the network, and it's like you would never ever notice that if you didn't run Valgrind. So it's like it's something to actually be scared of. So what file we're working on? Event loop test. So let's change our echoer to have like an ID, and we init this guy with a ID. Okay. And when we echo back, we're just going to write down our ID as well. So we're going to say before we write it, we do this, we're going to say, hey, I came from std format buff print into some buffer. I want like ID colon space, right? So the idea is that we're going to spawn multiple echoers at the same time, and we should see that when we type hello, we get like hello from 1 and hello from 2. We want both of those things to show up, and then we want to make sure that we don't have any leaks in the case where we have like multiple guys registered for the same thing. So we need const s is equal to this. S. Don't worry, it's the NSA. They're friendly. Yeah, super friendly. I wouldn't worry about them at all. Buff is like some 2024 U8 undefined or something. I don't give a fuck. This can probably be like 50 to be honest, or like 5. 5 is way more reasonable. Read declarations. So we'll call this ID buff, I guess, so that we can do this. And we can run to Valgrind again. Fuck it. Fuck. So when we create this guy now, we want to make 2 of him. Right? So here we have echoer and echoer 2. Yeah. So this is echoer handler and echoer 2 handler. Yeah. Oh, oops, we have to write 1 and 2 here as well. All right. Fuck. It never compiles. 93. Oh, oops, because I put the 1 and 2 in the wrong spot because I wasn't fucking thinking. Fine, we'll use our heads just a little bit, and we'll use it to find the right function call. Fuck. We need to write try here. Okay, so now we go back here, we tell that in, we say hello, and we should see 1 colon hello, no 2 colon hello, which is a little concerning. Okay, so we're not calling all of the handlers when we should be. That's not good. That is not good. So here, like we are hello? Like what the fuck is going on? It's weird that it was alternating between them too. That's really fucked. So let's std debug print. We have this many handlers. items len. It's a hard life out here. Okay. Telnet, hello. We have one handlers, we have two handlers. We have two handlers. I wonder if they're fighting for the TCP socket? Yeah, there's something fucked going on there. It's so maybe we look at the callback here. And we can at least log here. Echo called for this number. Telnet, hello. Echo called for 1, echo called for 2. Well, yeah, what the fuck is going on? Oh, fuck. I see what's happening. They're both trying to read from the socket, which is, like, not okay. Right, so we're... Oof. Woof. Which kind of makes it feel like having two readers for the same file descriptor is like a bug. Because it's like a consuming read. Which kind of makes it seem like everything that we just did was a fucking waste of time. Right? Because really what we should do is we could I guess we could have many writers. Many writers is legal, it's just one reader is a problem. So for now, I wonder if there's a way. Let's do this. Here, we can fix this. We can fix this. We can, when we run our echo thing, we'll just make a global variable. Yeah. Of 100 U8s. Right, this is not, don't worry about it. Don't worry about it. And we'll say var buff len is a U size. Okay. And when we read, we will try to read. So we will set the connection as non-blocking. When we initialize this thing, so we'll say set non-block on connection stream. And then when we read, we will read into our global buffer. And we'll say buff len is equal to this. And we will catch a wood block. And we'll just say this, I think. Okay. This feels fine, maybe? I guess, yeah, we'll see. We will see. So now both of these guys should be able to make it through this without a problem. And then we can run them both, I think. Fuck. How do I do this? I have to like make this like a block. And then break block bufflen like this. No, block like this. Block like this. How the fuck do I do block like break zig? Block colon squiggle. And then like this. Yeah, that sounds right. Zig build. Value of type usize node. So here I also have to do break block this. There we go. What a disaster. But maybe this will work now. At least enough to test it. So telnet. Fuck. Not open for reading. Hello? Okay, so this is really fucked up. Telnet localhost 8000. Failed to run callback, error not open for reading. Oh, but we did echo called for 2. Let me think. Not open for reading. Where is that coming from? Oh, it's here. We're probably deinitializing ourselves when we shouldn't be. Oopsies. Telnet? Okay, wait. Oh, God. That's something. Why was it doing that? Maybe we do this. I'm not sure. So it's just spamming it. Fuck me, man. Or move block after catch. Oh, interesting. So you do like here. You guys are saying this works? Oh, nice. Okay, so this is annoying. So why is this getting spam called? Oh, because maybe it's polling again on right. Hold on. Out. Let's get rid of this and only poll on input again and see if that fixes the problem. Telnet? Localhost? Hello? Oh, there we go. Okay. Solid. Okay. So we have some proof that it works where it's like calling multiple at once. We can't like deregister these things correctly because they're trying to like share a read handle, but it does look like it's like kind of working. So let me like undo some of these changes that we just made because I don't want them to stay there. And I think we have at least some form of confirmation that it works okay. Okay, so we have now the ability to register multiple handlers for a single file descriptor. Wonderful. That was a lot of time, an extra hour spent on that. So let's go back to async TCP send and receive. So we have our TCP writer that we wrote at the beginning. And he should now be able to be registered with this thing. And we will just, on our echo server, instead of calling this write all here, we want to register with the event loop. A new writer. So we want like self or TCP writer init with self allocator, self connection, and some buffer that we want to write. Okay, so we will, if we're echoing what we got in, we are going to, I guess, allocate that thing. So this is going to be the red bytes size. We're going to allocate some U8s. So const to write is equal to this. Oh, or maybe what we'll do is we'll make him own it inside. So we will maybe say buff from 0 to red bytes goes here. And then inside he will say alloc dupe u8 buff. So copied is equal to this. Error defer, we free copied. And then down here, our buff, instead of being buff here, is copied. Here we go. Then we need our D init needs to free that guy. So self alloc free self copied. Or buff, I should call it here. And then we should just be able to register this thing. So here we're going to say var writer is equal to this. Const writer probably. And then handle, event loop, register, for self connection stream, handle, this new writer. The writer's handler. Okay. Let's see what happens when we do that. So we need to make that handler function, which is going to look a lot like this, but for writer. So it's kind of the same thing that we did earlier, where before we were like storing our handler internally, but we don't need to do that anymore because of our like refactor of the event loop. So this kind of goes away, and then like this stuff all kind of comes down here. And this just becomes like a return. And then we have this problem where self is shadowed, so we're gonna rename this guy, oopsies, what the fuck just happened, to writer or something. There we go. Data is self, I guess. And then I think that's fine. Fuck! It's never fine! It's never fine! Right, because this is the wrong thing here. This is a TCP writer. No function name handler in this thing at 161. So here we have to write try here probably. No field name handler at 40. Right, so we don't need this anymore. It's fine. Copied needs to write try. Fine, we will try. Error union is discarded at 160, so you have to write try. Value type ignored, so here we discard this, we don't need it. No file descriptor at here, it's fine. No field handler here, that's fine as well, we deleted that. And if everything worked right, we should see this do something. Okay, so that's good. We do see him echoing back, but then we do see a connection close, which is a little bit surprising, as well as a bunch of like uninitialized memory accesses, which is bad. So this is happening at TCP writer write line 71. What's going on here? Self buff IDX and buff, self buff. Okay, let's see if it's like related to the fact that we're spawning multiple echoers. That's going to be a bit annoying. So let's just delete that shit that we don't need that anymore. Telnet, hello? Yeah, so why is he closing it? That's also kind of weird. Conditional jump or move depends on uninitialized values. Oh, conditional jump or move depends on uninitialized values at that line, right line, is probably because we are using, is like self buff IDX not initialized yet? No, we initialized that to 0. This is in the middle of TCP writer right. And it's doing that every single time. Oh. Well, we should be writing only to the buffer length, but we only copy the buffer length here. Is it because here do we pass in the right thing? We only pass in the number of bytes that were read. I don't understand. I do not understand. Also, why is it closing itself? Oh, because when we finish writing, we close the connection. So maybe we shouldn't do that. Maybe we should not do that. Okay, that's a little better. Now we're seeing spam calls of would block here. Did we close the connection here still? So it's like almost working. Almost working, except for this echoer is getting a would block, which seems fine. So what's it? Do I have to? Am I not like clearing some epoll event that I'm supposed to handle? Like, I think I read somewhere that epoll is like edge triggered or level triggered. Like, man, epoll. Is it possible that we were just hiding a problem before and didn't notice? Like when I finish with my event, do I have to do something? So they get for each connection, they accept a thing, they set a non-blocking thing. Edge triggered here, they set. Epoll edge triggered. Epoll edge triggered. When used as an edge triggered interface for performance reasons, it is possible to add a file descriptor inside the epoll interface once by specifying epoll in out, continuously switching before in and out, calling epoll CTL with epoll CTL mod. Oh, I see. Okay, let's try that. Let's just see what happens if we do that. Maybe it'll do something same. Maybe. But maybe it won't. That feels okay, other than the fact that we have all of these warnings about conditional jumps based off uninitialized memory. Oh, we're one behind. Interesting. Interesting. Oh, because he's only going to call himself when the next iteration. So here we need to make sure we do at least one write immediately. And that should always be okay. So here we'll say writer write with event handle. But this is the wrong handle. Ew, this is nasty. It's almost like on registration, we should call this thing one time immediately. It almost kind of feels like that. Because he has like the new handle here for the thing he's made. So this is a handle. And we just immediately call handler. Ugh, gross. Except for I can't call it here because this is from like the wrong calling context, maybe. Right? Like, what if we give out this handle? Somebody calls register from like another thread where they want to register something with the event loop. I guess we have no mutex protection or anything, so that can't happen right now. So that's probably fine. So we'll say const handle is equal to this. It's probably fine. We are going to call whatever the fuck our handler is. Call back with handle and handler data like this. And I guess we'll write catch here. And we'll just say stood log error failed to run handler with this reason. Uh-huh. That seems okay. Then we have to return the handle still. It's fine. It's fine. This has to write any. Oops, wrong word. Okay. Telnet. Echo called for 1. Hello. Hello. ASDF. 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 Hello. ASDF. Hello. ASDF. That feels okay. Yeah, it feels all right. Now, so this stuff is still really concerning to me. This conditional jump or move depends on uninitialized bytes. I would like to understand why that is happening. So maybe we can GDB event loop zig 71. And just kind of like poke around. So self buff is hello slash r slash n, length 7. Seems reasonable. 1, 2, 3, 4, 5, 6, 7. Yeah. Self. Nothing in here seems super fucked. And then I print next and it prints the right thing. So what's the fucking problem? Yeah, I don't get it. I don't get it. So it's coming from event loop zig 296, event loop zig 71. Let's see if this goes away. So here, let's make sure that like this buffer isn't going anywhere. No, this gets copied. So we shouldn't be working with like any uninitialized memory. Then when we write, it's here. Yeah, there's like, I feel like there's nothing that could be fucking going wrong here. Let's just try doing something crazy, like drastic. Like clearing out the buffer or something. To see if that adjusts like its belief in what is valid and like what has been assigned memory so far. Fine. So here if I telnet in, I say hello, it's ooh, okay, wait, that's something else. Sig abort at memset of self buff. Wait, that's a really good sign. That's a really good sign. Invalid write of size 8. Address is stack. Okay, wait, what the fuck is going on here? What the fuck is going on here? This is good clue. Self.buff is AAA. What's self? Self is also fucked. Okay. So something here is just fucking broken. So we create a TCP writer. We return that thing. We get its handler, which comes from the TCP writer. We set the data pointer to the pointer that we made here. So self buff is on in it. It looks like the whole self pointer is on in it. like this is also invalid. And like the pointer to allocator is also uninitialized. It's like the whole fucking thing is invalid, which is confusing. Like, are we doing something absolutely brain dead stupid on register? Okay, let's say that here, we are gonna say std debug print created writer at this address. Then here, when we get our handler, we're gonna say self in handler generation is self, right? And then down here, when we call the fucking guy, we're gonna say calling callback with data this thing, and this is gonna come from handler data. Let's just see if there's like a fucking obvious mistake in there. Maybe there is. Hello. Okay, so we created writer at this address. We're calling callback with data here, which is fine. This is the other thing. Then we call with the same data. So we created this thing. We used the correct pointer in the handler generation, and then we did this. Okay, so is it possible that we are de-initing this thing by mistake? De-init. Telnet, hello. He is de-initing. Why the fuck is that happening? So we can maybe GDB here, breakpoint on this, run it, telnet in, send something, and where's this coming from? This is coming from TCP writer right at line 71. Oh. Sure. That makes sense. So when we de-init, are we just, that's correct. We finished writing, and we should de-init ourselves. So then the question becomes, why are we getting called again? That's the bigger issue. So we are getting to here, that's fine. This is not running, which is fine. But here we should have removed the handler. And why the fuck is that not happening? Removed handler with data at this pointer. Handler data or something? Handler data. I'm pretty sure this is it. Let's see. Hello. So we removed handler with data this. Okay. Then we called dinit. And then we just tried to run it again anyways. This is at line 303. What the fuck have I done wrong? I feel like it's not that hard. Calling callback with data. Yeah, so we called callback, we removed the handler, then we de-init. And then we're somehow in it again. Handlers, items, self new handlers get. Oh, fuck me. Invalid pointer, invalid pointer. Invalid pointer. Maybe. This needs to be like items, self alloc dupe this, and then handlers. Oh my god. It's a hard life. Defer self alloc free handlers. Okay. So for context, what I believe I'm looking at here is we have, hello, pointer, could you catch up? Thank you. Oh my god. Okay. So we have like a map somewhere of like file descriptor to array list. Array list is like len pointer, right? And so what this kind of means is that like at some specific memory address, you have handlers to run, handler 1 and handler 2, right? We then say in our main loop or our event loop, hey, I would like to go to this pointer, please, and I would like to iterate this length, right? Fine. And then we might modify this pointer while we're iterating. Bad. Because like, say that we like push to this array list, for example, and the array list like length is like 1. He's gonna be like, oh shit, this pointer isn't in the right, like this pointer isn't big enough to hold the amount of things that I want. I'm gonna resize myself. And so then like he just gets a different address, but we're still iterating the old address. That's like a possibility. I don't know if that's like the problem, but that's a possibility. So that's why I changed this here to like duplicate the handlers out completely. So we instead of iterating from here, we'll say like, hey, let's like snapshot this list here, and we'll like write it down over here and then run it. I don't really see why that would be the problem, to be honest, but it does seem invalid. So we are going to do it as an attempt to fix whatever fucking invalid memory access we have going on. Fuck! Then everywhere we write items after this, we have to delete it. We actually tried to do that before, and we just made a mistake when we did our snapshotting. Because we are stupid. Okay, so it is still fucking busted. So here, calling callback with this thing, we removed handler with data this thing, D in it, then why are we calling this again? This is coming from callback. I'm still missing something. For each event, let's log here. Stood debug print event on FD. This says FD here. Event on file descriptor. Then we rip through these guys. And then at the end of this, we'll say stood debug print finished iterating handlers. Right? That makes sense. Telnet, hello. So here we are saying event on file descriptor 5. We have 2 handlers. Calling this, echo called 1. Oh, fuck me. Wait, hold on. I think I know what it is. Fuck. No, wait, let me think. So we register a handler for writing in the echo, like on our read. We get a read, we register a new handler for writing. We immediately call that handler, and he probably immediately deregisters himself, to be honest. Let's see. Function. Oh my fucking god! No! No! It's so simple. It's so fucking simple. We just de-inted ourselves and then didn't fucking return. Oh! Oh my god. I'm gonna lose my fucking mind. I deleted the return earlier to fix something else. Yeah, because it's not fucking doing it. It's supposed to go down here. Oh, it's still not sending my shit back, actually. So now it's just not doing anything. Why the fuck is that happening? Oh, because I'm writing mem setting to 0 like a fucking dumb piece of shit. Telnet. Oh my god. We did it! Well, try to be happy. I'm so mad. I'm so mad. It's so obvious. So this is you know, sometimes we say, "Hey, man, we can do it. We can just let me do what I fucking want." And then what I fucking want bites us in the fucking ass. And it's like, "Fine. You know what? I deserved this for thinking that I could do better." That's annoying. That's really frustrating. What a waste of time, but this is the cost we pay. The cost we pay, the price we pay. This is the cost of doing what we're doing. Oh man, that's frustrating, but it's okay. We'll live. We'll live. So all we did get to the point where this async TCP send is now working. I think. Let's try to prove to ourselves that our initial failure case, where our program would stall if we tried to write 10 megabytes of data to somebody who wasn't listening, it shouldn't stall the program. So what would be kind of cool is if we could add something to the event loop that maybe it like just triggers every 10 seconds or something, right? Then we'll have like, or every 1 second, we'll have a log of like some counter incrementing, and then we'll know that that thing is happening, and that thing should keep happening even if somebody isn't listening to us. I think that makes sense. Or hold on. What we could do is instead of doing that, just here we will register another handler here. Handle 2. And this handler will be maybe a TCP writer of a big value. Yeah. Stood alloc. Stood. Sorry, alloc. 10 megabytes of shit. So what, like var data is equal to this, defer data alloc free data. Nice. Then here we are going to say var writer is a TCP writer initialized with our allocator. Some connection that we have to make. So stood const send addy is stood net address init IP4. We're going to send to our local host, and I guess we'll change the port number to 8001. So we're going to try to send to someone on 8001 who's not listening. So we're going to say stood net TCP connect to address send addy. We'll try this, I guess. And we'll say const send connection is equal to this. Then we can create a TCP writer that sends this data with this send connection and data. And we can register send connection stream handle with writer handler. Think that's how this works? And then we'll say memset data 0. Why does it think this is never mutated? It is mutated. Do I have to write ampersand? No. Oh, it's because this can be constant. I see. Because it's the data that gets modified, not the pointer itself. Okay, so you go back into test 2 here. And here we should be able to change our port that we're listening on to 8001. We should be able to zig run test 2. And zig build and run our event loop test. Look! 361. This guy takes in a connection, but we're just going to change him to take in a stream. That makes more sense, to be honest. Okay. So here we delete that. Then we're chilling. And then somewhere else, we just have to make sure that when we make him in our echo server, that we use connection.stream here. Okay. Does that build? Close. 362. Send connection dot handle. There we go. Okay, Zig build and run. Okay. So now, hold on, let's run this again. He should fail. No, he doesn't fail. Why the fuck not? Oh, because this fucking blocks. Fuck. Okay, we'll do it the other way. This stuff goes up here. Now this should crash because the port isn't open. Great. Now we run this, and if we telnet into this thing, we should see that this like echo service still runs, which it is. So I think that that's pretty reasonable proof that our async TCP thing is like working, right? So before, at the beginning of the stream, we tried to send 10 megabytes of zeros over to our test 2, which wasn't listening, and that blocked the whole system up. Now we have our like async TCP writer, and that's not happening anymore, which is great. So I think that we can maybe prove that this should still be broken if we don't set non-block here. I think if we do that, we can run our test again. Oops, Zig builds. And what we should see here is that this telnet no longer doesn't answer us anymore. Perfect. Perfect. Okay. Okay, so I think that was a long and painful journey to get to the point where we could do async TCP send. And it was only painful because we were fucking stupid and we messed up a bunch of times. But you know what? It is what it is. Sometimes you have those days and you just gotta live with it. And now we will be scared of whatever caused our problems before. I actually don't even know. We probably won't be because I'm having trouble even processing what the problem was. It was that we forgot to fucking return after we deneted something. We just use after free, man. Classic problem. Why would you choose Zig rather than Go? Because you want control over your like program. You know, like for a lot of people, garbage collection's a no-go. For me, it shouldn't be a no-go, but I've kind of lived my whole life in this world of like manual memory management, and like I really like the idea of playing around with stuff that's like really low level. So Zig kind of like enables that, where I think Go, you have a lot harder time with like just like what is happening. But then again, I haven't really written any Go, so that's another reason. What IO muxing function are you using? We're just using epoll. We are just using epoll. So we have our little event loop that registers. We changed it today so that it registers with epoll, and then epoll will say, hey, I found some things happening on this file descriptor, and then we like rip through basically a bunch of like handlers that we've registered for that file descriptor with the ability to like unregister ourselves. So a lot of the work is done in like our event loop class itself, but epoll is like the notification mechanism for like it's time to do something, right? And so this actually should end up resembling something that's very similar to like Rust's async runtime, right? Because Rust's futures are modeled around this idea that like somebody's going to tell you that you should do something. We're going to call this poll function on you, and you will tell us if there's something that like, are you done? Do you need to be polled again later? And so this is like the same shit. But yeah, okay. We did it. Unfortunately, that means that the actual work that I wanted to do today, which was HTTP request parsing, like doing the HTTP server, is going to have to wait till tomorrow because we spent 2 hours on just getting a good TCP send going. So, and it's not even good. So, if you want to check that out, you can swing back by tomorrow at around 2 o'clock Pacific time. We stream for around 2 hours a day. If you're new here, there is a YouTube link in the Twitch description where all of our previous projects are kind of thrown up here. So if you want to check out terminal emulator, operating system, neural network, Huffman trees and zlib reimplementation, QR code decoder. There's a lot of stuff in there if you want to go check it out. Things that are I find fun, which trends towards low-level reimplementations of things that already exist because we fucking feel like it, right? There's a GitHub link in the Twitch description as well if you want to check out code for this stuff. This will probably end up in the ball machine repo, not necessarily in its exact current form, but it will end up here because we do need to handle multiple HTTP requests from from our server at some point. We're also working long term right now on this collaborative Rube Goldberg machine. So if you want to check that out, we're going to be working on this system where users can upload WebAssembly modules. And those modules will run physics simulations. So, kind of something like this where you have moving platforms that's defined by WebAssembly. So if you guys want to check that out at some point, I mean, I shouldn't say check that out. It's not done yet, but when we get done, you guys can write some code and upload it and we'll run it and it'll be kind of fun. If you're watching on YouTube, there's a Twitch link in the YouTube description where you can swing by and say hi. Subscribe, Twitch Prime. Goodbye, YouTube, and Twitch. Let's figure out who to raid.